بسم الله الحمد لله والصلاة والسلام على رسول الله. الطلبة الأعزاء، السلام عليكم ورحمة الله وبركاته، وأهلا ومرحبا بكم في هذا الجزء الثالث من المحور الثالث بعنوان Thread Drawing. To make a representation for thread, we have three types of representations. First one is called detailed representation. Second one is called schematic representation. And third one is called simplified representation. And this one we will use it during this course. Detailed representation. Use slanting lines to represent crest and roots. Roots and crest are drawn in sharp VS. This is a detailed representation. This is external thread and this is internal thread. Thread run out in this region. For the schematic representation, use alternate long and short lines for representing crests and roots of the thread, respectively. So here, long lines, it is for crests. Short lines, it is for roots. Same to internal thread. Okay, this is the pitch. For the simplified representation, and this representation will be adopted and used for this course, use thick continuous lines for representing crests and thin continuous line for representing roots of the thread, respectively. So here we have the root, and here we have the crests, okay? And this is this chamfer, it is pitch, half of pitch, okay? This zone or region, it is the thread ran out. Here we have sectional view for internal thread. You can remark here that dashed line, hatching lines will cross the root lines. Okay. Isometric threads. This is external thread for isometric threads. This is the internal thread. This is the center line of the thread assembly. Here we have P/8 pitch, here pitch/4, and this is the total pitch P. Here we have 60 degrees for the isometric. Thread assemble occurs if only both internal and external thread have an equal nominal size or diameter and pitch also. Otherwise, assemble will not occur. Some examples for metric coarse threads. The nominal size with symbol for 6 mm, for example, it is M6. That means the measured diameter is 6 mm. Here, because it is coarse, pitch is 1 mm. So minor diameter, it is 4.92 mm. But the tap drill size will be about 5.92. It is 5 mm. This is standard size. For M8, for example, here 8 mm, the pitch is 1.25. If the minor diameter it is 6.65, so the tap drill size will be something standard 6.75. M10, the measured diameter or nominal size will be 10 mm. The pitch will be 1.5 mm. So the tap drill size it is 8.5 mm and the minor diameter will be 8.38. Let's move now to see. In the symbol, M it is for metric thread, and the number here it is the measured diameter or the nominal size. Minor diameter and tap drill size, the dimension will be the same almost 10.11, and here 10. This should be standard. In the 3D drawing, the following relationship is used. So minor diameter is equal to major diameter minus the pitch. Let's move now to metric fine thread. For M8 thread, nominal size is 8 millimeters. So the pitch it will be, we have two possibilities, 0.75 or 1 millimeter. If we compare that with the coarse thread, for 8 millimeters, last slide here show us the pitch is 1.25. This is coarse, but here for fine it is 1 or 0.25 or 75 millimeters because it is fine. Same to M10. So the pitch will be between 0.75 or 1.25. Here in coarse thread, for 10 millimeters, we have 1.5 millimeters as a pitch. Same remark here, minor diameter should be almost equal the tap drill size. In thread drawing, the following relationship, it will be the same relationship. It is minor diameter equal major diameter minus the pitch. Here, we will present the drawing steps of external thread. First, you have to start by drawing thread axis. You have the measured diameter here. Starting position, you have to fix it by this line. You have the thread length. And you have the minor diameter. Start by drawing chamfer 45 degrees. And here with 30 degrees. Okay. This is external thread. This is center line. Okay. Now, for the side view, start by drawing circle that represents a crest. Draw an arc that represents a root. It should intersect here, okay? And not continuous circle, it is arc. Axis, this is side view. Drawing steps of thread hole. Throw threaded hole. Center line. You have the major diameter. You have the minor diameter. Draw a root. It is dashed line. Draw the crest. It is dashed line too. This is the center line. Because it is sectional view, now each dashed line will be continuous line for crest and for roots. And hatching line will cross the root line. Okay, with the center line here. Side view now. Draw a circle that represents a crest. And the arc should be outside the circle. And should cross one of the axis lines. How to draw blended threaded hole now? Draw the thread axis position. You have the hole depth. You have also thread depth. You have the minor diameter. Okay. Draw these lines with 30 degrees. You have the major diameter now. Okay, this is the root. And now, this is the crest. Okay, this is a center line. How to make side view? Starting by axis position, draw a circle that represents crest. Okay, and draw an arc that represents root. It will be outside the circle. Now for sectional view, roots lines and crests lines will be continuous line, and the hatching lines will intersect the crest line. Dimensioning of external thread. Use local node to specify thread form, nominal size, pitch, if it is a fine thread only. This is M10 if it is fine or gross. Here it is coarse, okay, but if it is fine, you have to put here, multiply it by 1, okay. Use typical method to specify threaded length. This is the thread length. How to make dimensioning for threaded hole now? Use local node to specify tap drill size, drill depth, thread form, nominal size, pitch, and thread depth. We have an example here. 8.5 drill. This is local node to specify the tap drill size. 20 millimeters deep. This is M10 as a nominal size. Tap it, and 15 as a deeps, for example.